Hi everyone. Today we continue talking about exponential transformations. And we've talked about translations, so shifting left or right and shifting up and down. But now we want to talk about reflections. And this is for all exponential functions, not just growth and not just decay, but all exponential functions. This is how you reflect them. So here's a refresher. The parent function is f of x equals a base b to the power of x. It says the parent growth function, but really it's just the parent of the exponential functions. Remember that the base b has to be greater than 1. It has to be positive. So it's okay if it's, 2, 3, 4, 5, or so on. It's okay if it's 1/2, 1/3, 1/4, 1/5. That's okay. It just can't be negative. And today it's going to seem like our base values b are negative, but they're not. So when we perform a reflection, we flip the parent function over the x-axis, so it's a transformation that's a reflection over the x-axis, and really what happens is we end up with a -1 out in front being multiplied by the base to the power of x. So it's sort of like, it's sort of like g of x, because f of x is the name of my parent function. So this translated function would be g of x equals, and then some a value times b to the power of x. And you've seen this before when we've talked about word problems. That a value, what we've talked about in the past is the initial value, but this a value here is the reflection. It's the negative that you've come to associate with reflections this year. So even whenever, take for example this problem, even whenever you have g of x equals -2 to the power of x, it's not -2 that we're raising to the power of x. It's what's directly to the left of it. So this 2 is the b value, the base, and this negative, or -1, is the a value, indicating that we have a reflection over the x-axis. So just keep that in mind, that even though we have things like g of x equals -2x, -2 is not the b value. 2 is the b value. This negative indicates that a is -1. So let's do some examples. We have a graph of a function like this, and if it's going up from left to right, then this would be exponential growth. Right? Exponential growth. We can also see that the distance, the vertical distance, as we increase 1 unit, as we go 1 unit more along the x-axis, the distance is getting much bigger, much faster than it is if we were going back this way. It would be getting much smaller. So the change is increasing as we go to the right, and we call that growth. Now the initial point that we've spent so much time talking about, this is the initial point, or the starting point, or the initial value. That's the a value that you see. And remember that in order to find the base b, you go 1 unit to the right if it's a growth function, and this vertical distance right here indicates the b value. So here a is 1, because that point is going through 0, 1, just like the parent function, and the base b is 2, indicating that we have exponential growth. Now, in this function, we have the same thing except for a of -1 has been applied in the front. And that means that we get to reflect this graph over the x-axis. Sorry about that. So what used to be a point at 0, 1 and a point at 1, 2, so 0, 1, 1, 2, now has been reflected over the x-axis. This point goes down to the axis once and past it once. Here it is. There's our new initial value, our a value. And then this point goes down 2 and down 2 more, and then ends up back on the graph. This is still, because it is a reflection of a growth function, it's still considered growth. Even though it's going down like that, it's still considered growth. This distance from the graph to the horizontal asymptote when you go 1 to the right, that's still the b value. So the a value is now -1, and the b value is still 2. Still 2. All right, so let's go down to our next pair of graphs. we have f of x equals 3 to the power of x, the parent function with a base b of 3. I know that because my initial point is right here. There's my initial point. And if I go 1 unit to the right and I count that vertical distance from the asymptote to the graph, that's a distance of 3. So that's my b value, that's 3. And the initial value, that's the initial point, that's 1. This is exponential growth because from the left to the right, we are increasing the change, and this is growth. Now, if you take an a value of -1 and you apply it to the front, that means that we've taken what used to be a nice, pretty growth function like this, going through 0, 1, and 1, 3. We've taken it and we've reflected it over the x-axis. So it comes down here. That distance of 1 to the asymptote is the same past the asymptote. There we go. And that distance of 1, 2, 3 to the asymptote is the same past it. 1, 2, 3. Another point. So this is a reflection of an exponential growth function. The a value, because it's been reflected, is -1. It's also where it's going through the y-axis right there. And then the b value is still 3. I still have a distance from the graph to the asymptote of 3. So let's go to our next examples. Here we go. Remember that the parent function for exponential decay is the same as for exponential growth. It's f of x equals b to the power of x. But this time, because we have a decay function, base b is between 0 and 1. It doesn't go into the negatives, but it is less than 1. So it's some kind of fraction. Remember that f of x equals b to the power of x flips over the x-axis when you have an a value of -1. So our first graph, we have an exponential decay function. Our initial value is right here. So that's a value of 1. And then the b value, since it's decay, we don't want to go to the right and count that distance because that's going to be tough to measure. We want to go to the left 1, so 1 over, and then count that vertical distance. 1, 2, 3, 4. There we go. So that distance right there gives a b value of 1/4. All right, let's look at the next one. Same b value, but this time we have an a value of -1 sitting right here. Now this function is still decay because it's the reflection of a decay graph, but we want to reverse and reflect this over the x-axis. So here's the x-axis. My original graph had a point at 0, 1, and at -1, -4, or sorry, -1, +4. I'm going to reflect over the x-axis, so I'm going to go down 1 and down 1. There we go. That's an a value of -1. And then here I'm going to go down 1, 2, 3, 4, and past it 1, 2, 3, 4. So my b value is still 1/4. My b value is 1/5. I can tell that because my initial value here is 1. So a equals 1. If I move 1 to the left and I count my vertical distance, 1, 2, 3, 4, it actually goes up to 5. There's a little bit of space between that line and the curve. So my b value is 1/5. This is an exponential decay function because it goes down and starts to flatten out over here. So the amount that it's changing is kind of decreasing over time. That's decay. I'm going to take that same function that has a point at 0, 1, and -1, 5. And I'm going to reflect it over the x-axis. So this point shifts down 1, and then it goes down the same amount. Here we go. This point will go down 1, 2, 3, 4, 5, and past it 1, 2, 3, 4, 5. There it is. This is still the initial value, so my a value is -1, which makes sense because the -1 appears here, causing the reflection over the x-axis. But my b value is still 1/5. It's not negative because that's the a value. The value that is being raised to the exponent is a positive 1/5, indicating that this is a reflection of a decay function. Okay, so we have some examples. First thing that I think is a good idea is to put your horizontal asymptote in there. So I see that the graph kind of starts to flatten out right here. So my horizontal asymptote is right here. Going through a y value of -2. So y equals -2 is the horizontal asymptote. I notice that instead of going up or flattening out and down, it goes up and flattens out. So that means there's been some kind of reflection here. My initial value used to be right here, but now it's over here. Let's undo that reflection that we see. So this point here needs to go up 1 and then up the same amount. Let's find another nice point, maybe right here. That point needs to go up 1, 2, 3, and up 1, 2, 3. Here we go. So here is what the function should look like. That is an exponential decay function. The decay function had been reflected over the x-axis, so a's value is -1. The b value, the base, comes from going, because it's decay, from that initial value over to the left one and counting the distance between the asymptote and the graph. So 1, 2, 3. That value is 1/3. And then here is where that initial point moved to, and here's where it was. So it shifted 1, 2, 3, 4 units to the left, an h value of -4. And it shifted down 1, 2 units, so a k value of -2. So when you put everything together, the new function is g of x equals a, which is the -1, times the base b of 1/3, to the power of x with the opposite of h, so x plus 4, and then plus k, which is -2. So if that was difficult to follow and you were wondering where everything came from, remember that when you put everything together, all the transformations, you'll have a out front, you'll have b to the power of x minus h, and then you'll have a plus k at the end. So this is kind of the formula for how to do transformations. So let's look at number 2. Number 2, usually we have decay functions that come down and flatten out. We have growth functions that are flat and then they go up. This is neither, so that means that there must be some kind of reflection that happened. And here's the horizontal asymptote. That goes through a y value of 3. If there's a reflection, the a value is -1. Let's go ahead and undo that reflection so we can kind of see where the graph originally was. So here's a nice pretty point. Here's another one. So I'm going to go up 1 and up 1. I'm going to go up 1, 2, 3, 4, and up 1, 2, 3, 4. Now that we've undone the reflection, does that look like growth or decay? That looks like growth. The initial value was here. and now it's here. We moved 2 units to the right, 1, 2, so h is 2. We moved 1, 2, 3 units up, so k is 3. And we never found the b value. You go from your initial value, you go over to the right one, and then you count the vertical distance, and that distance was 1, 2, 3, 4. You can also count it here, 1, 2, 3, 4 underneath, because that distance that's reflected should be the same. So my b value is 4. So when I put everything together in the function, we have g of x equals a, which is -1, so we can just put a negative, times b, which is 4, to the power of x minus h, so x minus 2, plus k, so plus 3. Okay. Let's go down to the last 2 functions. What I'd like for you to do is pause your video and try to do number 3 on your own. I'll give you the horizontal asymptote where this starts to flatten out is going through y equals 6. You need to decide if there's some kind of reflection that's happening and then how to proceed from there. So pause your video and try to fill out all the pieces of number 3. Check back for the answer. Because we typically don't have the graph under the horizontal asymptote, that means there's been a reflection and a is equal to -1. If we reflect these points back up, we see that this is exponential decay. So our b value is going to be a fraction. In fact, if I go to the left one, that's a 1 in the numerator, and if I count that vertical distance, that's 1/2 for the b value. The initial value used to be here, but that point has moved here, so we moved to the right 1, 2, 3, an h value of 3. And then a k value of 6, because we moved up 1, 2, 3, 4, 5, 6. The function is g of x equals negative for the reflection, 1/2 for the base, x minus 3, because minus 3 is the opposite of 3, and then plus 6. So pause your video and try number 4. Because the horizontal asymptote is here at y equals 3 and the graph is underneath, that means there's been a reflection, so a is -1. We reflect these points back where they're supposed to be. We find that the original point moves from 0, 1 to here, so we've shifted 1, 2, 3, 4 units left, h is -4. And we've shifted 1, 2, 3 units up, k is 3. I put all the pieces where they belong. G of x, our new function, equals -5 to the power of x with the opposite of h, so x plus 4, and then plus 3 to shift it up.